Go.
Number of molecules is measured in moles. They're what you'll find in my Crocs soles. Or even though you can't see it, the air in their holes, through which you could stick poles. One is 6.022 times 10 to the 23. So to get a mole to molecule, use the calculator tool to multiply by 10 to the 23 times 6.022. Trust me, what's in this song about moles is very true. As true as Crocs are the best shoe, whereas of which there are too few. To stop yourself from arriving at solutions late, don't forget to be sure to scientifically notate, to use a number times 10 to a power, or be warned your future could turn sour. Moles are as interesting as Crocs, you see, and the calculation of relative quantities of reactants in a reaction is stoichiometry, which is very important across chemistry and in everyday life to you and me, because it shows reactions mathematically, making time free that you would have had to use an error in trial, so that you don't have to go the extra mile to figure out proportions that might be considered best and right. Of molecules there are a lot, so chemists went and sought a way to annotate so they wouldn't get irate over time past. And for ease, 1 mole of a substance mass can be found on the periodic table. Not very hard to be able to get grams divided by molar mass. Just be careful of the time you let pass if you're using stoichiometry to cook. Yes, unless you mistook how you can use moles for just being a way to measure Crocs soles. You can use it for products and reactants in everyday life. Don't worry, it's not that great strife. Say you're baking a cake, and in order to make it as good as can be, you need stoichiometry to estimate the reactants you need to make products fully created indeed, so that what you feed is reacted incomplete. No ridiculous feat with a calculator and some heat. It's so neat. Actual minus expected over expected yield isn't just something for farming a field. It allows you to calculate percentage yield that occurs when the reaction is fully healed. It is important in chem because it shows whether the reaction is coal or a gem. Whether under reality's distress, the total yield was more or less. A limiting reactant will stop the cooking of the reaction from going all the way, which is not funny any day. To find the formulas, first get the number of moles of each element by dividing percent composition, or number of present grams in current position, by the elemental grams per mole. Now to fix the next hole, divide by the least number of moles in the feast. Multiply to get integers you need, if you need to, but hopefully that's not the path you'll have to pursue. The molecular formula is the actual and truly completely factual ratio of atoms in a compound, simplified to the empirical formula easily without sound by dividing by the greatest common factor, so that the formula can be a little compactor. The empirical formula has ratios the simplest, simpler than all the rest, of atoms in the compound, present throughout and all around. To calculate the formula of a hydrate, don't go and hesitate. Simply take away the evaporated mass from the starting mass to be the best brass, and find out the water content through, or the water that away went. Then divide by grams per mole of the water and the whole of the anhydrous compound. Then the number of water molecules can be found by dividing by the of the anhydrous. Now that's a major plus, that you know the necessary molar ratio and the amount of H2O will allow you to know the compound's name. Now you're in the game. Trihydrate. Take the number of water molecules to know the fate. I don't want to smother, but in case you need another case of the importance of stoichiometry, I'll give you another upcharge free. If you were mixing up materials to make Crocs, world's best shoes, always worn without socks, and you needed to find your way out of the bind of getting the right amount and proportion for the needed fusing and conversion, and don't want to ruin perfect soles, you can figure out the needed amount using moles.